about. So we're talking about angle pair relationships. So these might be new concepts for you, possibly not. Our first is what we call complementary angles. Now this is different than I give you a compliment, because that complement has an I in it, not an E. These are complementary angles. Now if we talk about complementary angles, it's two angles that add up to 90 degrees. So for me to have complementary angles, I'm going to have two different angles, and as long as the degrees of both of those angles add up to 90 degrees, they're complementary angles. Okay, so let's do an example over here. Today is the 17th. All right, so in this angle, if we say that this angle is 30 degrees, what would be the degree of the complementary angle? Two angles that need to add up to 30, so the other one would have to be, or not 30, to 90, so the other one would have to be 60, right? So let's make it a little bit bigger. It's probably a little bit more than 60, but that's okay. So two angles that add up to 90 degrees would be complementary angles. Does that make sense? Okay, so complementary angles, angles that add up to 90 degrees. So what do you think supplementary angles would be? Two angles that add up to 180 degrees. So if I have an angle that is 100 degrees, what would be the supplementary angle to it? 80 degrees. Good. Okay, so complementary angles add up to 90, supplementary angles add up to 180. Okay, our next vocabulary word is adjacent angles. And adjacent angles are just like it sounds. Adjacent means next to. Adjacent angles are two angles that share a common vertex and side. Okay, so angle 3 and angle 4, they're two different angles. So if we focus just on angle 3, so angle 3 is right here. Its vertex is occurring where the 3 is. Its sides are the rays coming off the side of the angle. And then if I focus on angle 4, notice they share a common vertex, angle 3 and angle 4, right? They share a common side, which will be this side right here, okay? So those would be adjacent angles. Pretty much it's two angles that are next to each other. So they share a common vertex, they share a common side. Yes?
So if the 4 was on the other side, then the side would be the other arrow?
Right, so if the 4 was over here, then this would be the common side. Yeah. Okay? All right, so let's look at the example down below. We're going to determine whether the following pair of angles are complementary, supplementary, or adjacent. So looking at these two first, do they share a common vertex and a common side? No, they're separated from each other, so they're not adjacent. So now we have to look at the degrees. I have 115 and I have 65. 115 plus 65 makes what? 180. So would they be complementary or supplementary? Supplementary, good. So those first two would be supplementary. All right. Now let's look at this middle grouping. Are they sharing a common vertex and a common side? Yes. Does everybody see? What's the common vertex? At what point? B. What's the common side? Ray, what? BD would be the, ooh, that was bad tracing. BD would be the common side. So these would be adjacent angles. We don't know if they're complementary or supplementary because I'm not given any degrees in there. And then the last two would be what? Complementary, good, because they add up to 90. Okay, so complementary, supplementary, adjacent. So far, so good. Yes? All right, so next example, it says find the measure of a complement and the supplement. So if I'm telling you that angle 1 and angle 2 are complementary, the measure of angle 1 is 68 degrees. What does the measure of angle 2 need to be? 22. Yeah, so we're taking, so the measure of angle 2 is equal to 90 minus 68, which is 22 degrees. Pretty basic math, subtracting numbers. What would be the supplement for part B? So if they're telling us that 3 and 4 are supplementary, the measure of angle 4 is 56. How am I going to find the measure of angle 3? What am I going to do? What minus what?
Subtract 56 from 180.
Good. So 180 minus 56. So what is that? 180 minus 50 is 130. Take away 6 gets us to 124 degrees. So the measure of angle 3 is equal to 124 degrees. So far, so good? All right, let's flip on to the back and throw some algebra into the mix. All right, so for our algebra problems, we look at angle XYZ. How would I classify that? Is it acute? Is it right? Is it obtuse? Or is it straight? Angle XYZ. It is straight, right? It's a straight angle. So what should be true about angle XYW and angle WYZ? We think about angle addition, they should add up to how many degrees? 180, which makes them what type of angle pair relationship? Supplementary. Okay, so that means I've got two angles that happen to be adjacent that are going to add up to 180. So that means I'm going to take this angle plus this angle and equal it to 180, which is going to be our equation that we're going to use to solve for x. Okay, so 2x plus 14 plus 4x minus 20 is equal to 180. Now let's combine our like terms. My 2x, my positive 4x makes 6x. Positive 14 minus 20. Negative 6. Good. Equals 180. That's my next step. Add 6 to both sides. So 6x equals 186. Divide by 6, and I thought someone said 31, which looks good. Am I done? No, because what am I trying to find? Both the measures of the two angles. So, plugging in 31 for x for both expressions. Well, doubling 31 makes 62. 62 plus 14 is what? 76. So the measure of angle XYW is equal to 76 degrees. Now let's do the same thing over on the other side. 4 times 31 is what, 124?
Yeah.
124 minus 20 is 104. So the measure of angle WYZ is equal to 104. Now check it. Did we do it right? Do those two numbers add up to 180? Yeah. 176 plus 104 is 180. Good. All right, so the second problem, do we have supplementary angles? Yes or no? One to the right. Do we have a straight angle? No. Angle XYZ is what type of angle if we classify it? Right angle. And I know that for sure because of what? The little square. So now when I add my two angles together, what do you think I'm going to equal it to? To 90, because it's complementary angles that are adjacent. So my equation is going to be 2x plus x equals 90. Well, that's easy to solve. 2x plus x is 3x equals 90. Yep, divide out the 3 gets us to 30. So x is equal to 30. So what's the measure of angle XYW? 60, because it's 30 times 2. And then the measure of angle WYZ is going to be 30. Good. Okay, so you need to decide, are the angles supplementary or are the angles complementary? If they're supplementary, we're going to add them up and equal them to 180. If they're complementary, we're going to add them up and equal them to 90. So far, so good? Okay, so the last type of angles we have to talk about are what we call a linear pair, and it's exactly like it sounds. A linear pair. What do you think that would be? Two angles that do what? Share a line or make a line. They're making a line with our linear. What type of angle is a line?
Straight.
A straight angle. So you already have looked at a linear pair in that first algebra problem. Okay, so a linear pair are just two adjacent angles that make a straight line. So pretty much if we think about it, they're two adjacent supplementary angles. It's just we call them a linear pair. Supplementary angles do not necessarily mean they have to be adjacent. So a linear pair is a specific type of supplementary angle. So they're supplementary adjacent angles is what a linear pair is. So here would be an example. So angle 1 and angle 2 would be a linear pair. So do we understand the difference between supplementary and linear pair? Supplementary angles can be any two angles that add up to 180. They do not need to be adjacent. A linear pair would be adjacent supplementary angles because they're going to make that straight line when they're put together. All right, so we've got linear pair. And the last thing we have to cover are our vertical angles. And this is where they can get a little bit confusing. So vertical angles are two angles whose sides are opposite rays. So two angles whose sides are opposite rays. Now let's think back to what opposite rays are. So everyone right now in your example space, make a ray. What would the opposite ray of that ray look like?
Just like this.
Yeah, I would go in the opposite direction, making a straight line, right? So there's one set of opposite rays. Now off of that same vertex, make another ray. So right now I have a linear pair, right? So I know that those two angles have to add up to 180. Now from that ray, make an opposite ray. So pretty much what we have are two lines crossing themselves. But technically they're two pairs of opposite rays. How many angles do we have occurring here? 4 of them, right? So we have 1, 2, 3, 4 different angles. Now let's think for a second. Let's say angle 1 is 100 degrees. So if angle 1 is 100 degrees, let's just write it in there so we remember it. What would angle 2 have to be? 80 degrees. Good. If angle 2 is 80 degrees, what does angle 3 need to be? 100. And then what would angle 4 need to be? 80. So our vertical angles are the angles that are opposite of each other. So angle 4 and angle 2 would be vertical angles. And I know they're horizontally across from each other, but we call them vertical angles. Angle 1 and angle 3 would be vertical angles. And what's true about vertical angles? They're always the same. Use a better geometry term. They're always, starts with a C, congruent. Good. Okay, so we're going to say that angle 1 is congruent to angle 3. And angle 2 is congruent to angle 4. And those would be my vertical angles. Does everybody see vertical angles? Yeah. Okay. So angles that are across from each other is the way I think about it, vertically. So if they're across from each other, they're vertical angles. Okay, so let's look at this example. Identify all the linear pairs and all the vertical angles in the figure at the right. Okay, so linear pair. Why would angle 1, 2, and 3 not be a linear pair? Because there's 3. Pair means how many? 2. Where would there be a linear pair? 4 and 5. Good. So our linear pair, you can just set it there, Courtney. Thank you. So our linear pair would be angle 4 and angle 5. Is there another set of linear pairs? Where?
1 and 4.
Yeah. Angle 1 and angle 4 would be a set of linear pairs. Does everybody see that? Do we have any other ones? No, because 2, 3, and 5 would add up to 180, but they're not a linear pair. So those would be all of our linear pairs. All right, now let's do our vertical angles. All right, so we got to find angles that are vertical. So let's first start with angle 1. Does there look like there's an angle across from 1 that looks to be the same size? 5. Do you see how 1 and 5 are vertical angles? They share common sides. Well, not really sides. They share common opposite rays. Okay, so angle 1 and angle 5 would be vertical angles. All right, now let's go over to 2. I'm going to highlight angle 2. So angle 2's sides are here. Do I have an opposite ray from this ray? Yes. Do I have an opposite ray from this ray? No. So 2 doesn't have any vertical angles. Let's go over to 3. Does 3 have a vertical angle? Nope. This has an opposite ray, but this doesn't have an opposite ray, so there's no vertical angles there. We already covered 5. Does 4 have anything? No. I mean, 2 and 3 would combine, right, to make 4, but they need to be just 2. Vertical angles needs to be a set of 2. So that would be our only set of vertical angles. All right. All right, last one. What are we going to do? Someone tell me what the equation is going to be. Perfect. 5x plus x equals 180. 5x plus 1x makes 6x equals 180. Dividing by 6, x is going to be what? 30. So what's this angle's measure going to be? 30 degrees. What's the other angle's going to be? 150. Good. Yes? Not too challenging? All right, so we're going to do some practice problems.